Here we have a model of bone connective tissue. First, I'm going to go over all of the features that you'll need to know based off of our lab manual, and then I'm going to go over all of the additional features that might be helpful when you come to a test or a quiz from our lecture. So first off, we're going to look at the functional unit of compact bone. This right out here, what you see, what I'm pointing to, is considered compact bone. The functional unit is an osteon, which is represented here. I'm going to show you another model real fast. This is, let's see if we can see it. This is an entire osteon, or one singular osteon. It's not the greatest model that we have, so I just want you to know what this is and what it looks like. And then we're going to go back to this better model. So here we go. Again, an osteon is the functional unit of compact bone. The osteon is also known as the Haversian system. It's characterized, or it's comprised of rather, a central canal, which you can see here. From the top view, it would be just a hole in the center of that Haversian system, or central, or osteon, running down through that bone. We also have perforating canals, which can be seen here. Here they are, perforating canals. They're also called Volkmann's canals, but I'd bet you could say perforating canal on the practical and that would be fine. Right here, all these little brown dots, those are osteocytes. Osteocytes are mature bone cells, and they're housed in little spaces in the bone called lacunae. Lacuna is singular, lacunae is plural. So one osteocyte is housed in a lacuna. Lacuna comes from the Latin word meaning lake. So I like to think of these as little lakes that osteocytes swim in. That's not entirely accurate, but it helps me to remember. And from these lacunae, you can see these tiny microscopic extensions. And what they are canaliculi. Basically, they're microscopic canals between the lacunae in bone tissue that allows for the passage of nutrients. So in these central or Haversian canals, you'll see that there are blood vessels flowing through. And you'll also notice that blood vessels don't go to each osteocyte in particular. So the way that we get nutrients to those cells so that they don't die off is via the perforating canals, and then more specifically, the canaliculi, which allow for transmission of nutrients and other elements between these little cells. So that's all of the information that you need to know based off of our lab manual. Now I'm going to take a minute and just quickly go over all of the other features that are identified here. So right out here, this gray layer, that is called the periosteum. It's a membrane that covers the outer surface of bones, except for the joints of long bones. So you'll see this periosteum covering all aspects of the bones except for the joints. So think of joints like in your shoulder or your knee or in your hip. Then you'll see these little white projections. Those are called perforating fibers, but I like to call them Sharpie's fibers. That's what they're more commonly known as. And what these do is they secure the periosteum to the actual bone. So they perforate into these most superficial layers of the bone tissue. Then if we move over here, and I'm going to move this model a bit, and probably the recording too. Hopefully you can see this. All right, so in here we start to see trabeculae. Trabeculae is basically just a network of spongy bone that's been kind of hollowed out. So out here, I'm gonna move again, out here is compact bone. In here, in the inner center part of the bone, you would have trabeculae. You'll also see this gray covering. This is the endosteum, and endosteum covers all of the trabeculae, and it also lines all of those central canals and the perforating canals. So again, this is some extra information that you'll want to know for our test in lecture, but it's not information that would show up on a practical exam. For the practical exam, you'll want to know the osteon, the central canal, the perforating canals, osteocytes in lacunae, and canaliculi.